Hello everyone, and welcome to the NEATEC Electronics Series. This episode is about the sum of products, so let's get started. Alright everybody, so let's start off this section and have a brief review of the last video. Basically, we're going from a circuit, right? If you're given a circuit, all right, and you're going to end up with a truth table, right? So this is an example, okay? I just drew a circuit here, and you have an OR gate with two inverted inputs here, and you have an OR gate here, right? And an AND gate right there, okay? AND gate, OR gate with inverted inputs, and an OR gate, okay? So what is the expression, the Boolean expression, going to be after this gate right here? What's the Boolean expression going to be? Well, at this point, this is simply going to be A bar or B bar. Right? And this one down here, that is simply going to be A or C. Get it? Because you have an input from A coming in right here and an input from C right here, right? So what's your AND gate, the output of the circuit, going to be? Well, the output from your circuit's simply going to be A bar or B bar, right? ANDed with A or C. Now remember, when you're writing these out, don't forget your parentheses, all right? Very important, okay? Because then you wouldn't have the same circuit. So now let's draw a truth table, shall we? What are we going to have? We're going to have A, we're going to have B, and we're going to have C. Now those are your inputs, right? And let's say we have this coming down here, something like that. Straight as I can get it. So what do we have? 0, 0, 0, right? 1, 0, 0, 0, 1, 0, and then what? 1, 1, 0. Got it? Now let's keep on going. This is going to be 0, 0, 1, 1. What are we doing next? 0, 1. Then we're going to have 0, 1, 1. And finally we'll have 1, 1, 1. Get it? Now, let's look at the outputs here, okay? This method may help you solve larger circuits easier. So let's look at this output right here, shall we? It's going to be A bar or B bar, right? Put parentheses around them. We'll make a column here for you. So if we come down to that, if I can keep the line straight, keep the line straight, folks. Much better, huh? So A bar or B bar. Really, we're just looking at these two columns. C doesn't even enter into it, right? So think about it. A is inverted and so is B. So if A is a 0, you're going to have a 1 entering the OR gate, right? Because it's inverted by the inverter bubble. And anytime you have a 1 going into an OR gate, it's going to be a 1. Got it? So anytime A is a 0 or B is a 0, you have a 1. Got it? So this would simply be what? 1, 1, 1, 1, 1, 1, and then what? This would be a 0, and this would be a 0. Now let's do the next one. We want to look at the other gate, right? Which is this right here. So this will be A or C. Got it? No. Let's do the same thing. There we go. So anytime A is a 1 or C is a 1, we don't care about B in this case, right? So we're just going to look at A and C. I just put a little X over there for you. So anytime A is a 1 or C is a 1, the output is going to be a 1, right? So obviously this would be a 0. This would be a 1. This would be a 0. This would be a 1. And look, the rest of them, A is a 1, right? On all the cases. So this would simply be 1, 1, 1, 1. Got it? Finally, let's look at, we're kind of running out of space, so what I'm going to do here, just move it up and move it over out here for you. And I'm just going to call the output equal to Y, okay? This will be Y equals this, all right? So let's just do it. We'll call this Y. And we have two inputs to this AND gate. We have, this is one input here, and this is one input here, right? So anytime they're both 1, you would have a 1 on the output, and that's the only time. So here's a 0 and a 1, that would be a 0. You have a 1, 1, that would be a 1. This would be a 0. You would have a 1, 1, 1, 0, 0. Get it? There's your truth table. So with these inputs right here, A, B, and C, here is your output. All right, if I can draw that right, that's going to come like this. That's your output. These two here and here are intermediaries. They helped you solve it, right? But that's your truth table, okay? All right, next I'm going to give you a truth table, and we're going to discuss how you would generate the circuit. So in other words, we're going to be going in this direction, okay? All right, see you soon. All right, everybody, so at this point, suppose I gave you a truth table, and right here is one. I just wrote it down for you, right? So if this is your truth table, I'm just going to move this on over to the right just a little bit, just to give us some more room, okay? So there's your truth table. Now, suppose, as you can see from this truth table, we have 3 inputs. We have an A, we have a B coming in, and we have a C, right? It's coming in. It comes in to some circuit. We don't know what the circuit is, right? I'm just going to put circuit. And then your output here is Y, okay? And this right here tells you what's going on, right? If all of the inputs are 0, it's going to output a 1, right? Okay, so what I've given you, I haven't given you the circuit, but I've given you the truth table, right? So let's read this, shall we? What we're saying here is when A and B and C, so say it with me, A and B and C are 0, Y equals 1, right? We're looking at for values that are equal to 1 in this case, all right? Or when A is 0, right, B is 1, and B is 1, and C is 1, or when A is 1, B is 0, and C is 0. Right? So let's just write down what we said. So what we're saying is the output is equal to 1. So we can say that Y, right, we're saying that's when it's 1. That's going to be 1 when A, right, and B and C are 0, right? But the bar's over them, so A is 0, B is 0, C is 0. Or when A is 0, and when B is 1, and C is 1, right? That takes care of this one, right? We already wrote this one, right? So we have one more to go. Or, and we have a or sign, right? This is a plus signal. Or when A is 1, and we have B is 0, and C is 0. Get it? What we did is we just put down a Boolean expression for what we were saying in words. Got it? Make sense? Now, let me show you something. This is a product, isn't it? This is a product, isn't it? This is a product, isn't it? This is a sum, right? You know that's an OR gate, but it's a plus sign, isn't it? Plus sign gives you a sum, doesn't it? Do you see what we have here is a sum of products? We have 3 products here. We have 1 here, we have 2 here, and we have 3 here. So there's 3 products, and we have the sums of them. Hence, you have the term sum of products. Get it? So let's draw the actual circuit, shall we? Let's get rid of that, and let's move this over here. Now we have a sum of products expression. Sum of products, remember, is when Y, remember, sum of products is taken when Y equals 1, okay? There's another term called product of sums. That's different, but that's utilized when Y equals 0, all right? That's something else we're going to get to in a minute. But remember, sum of products is when Y is equal to 1. Now let's draw the circuit, right? And I'm going to show you something a little different here. Usually we've been drawing them horizontal, but as our circuits are going to get a little more complicated, I want you to draw them like this. We're going to have 3 inputs, right? Here's A. Right? Here's B. And here's C. Now, we're going to branch off of A. We're going to come down through an inverter. Pointing down, there's your inverter bubble. This is A bar. B bar. There's C bar. Get it? Now let's look at this one right here, right? This first one. Well, that one, basically, you're going to have to write a AND gate here. This is an AND gate, an AND gate, and we have A, B, and C inputs, 3 inputs, but they all have bars over them, right? So they've all been inverted. So if we take one, we're going to go from here, we'll go all the way over to A bar. That's A bar. The next one will go to B bar. And the next one will go to C bar. Get it? Let's do the next one, shall we? This first one will go to A bar. All right, we're doing this one now, this gate right here. So we'll go from here, we'll go back. A bar, right? Then we go, the next one is B. There's B. And then the next one we go to C. Got it? And finally, let's do this one. A, B bar, C bar. There's your AND gate. We'll go from here, we'll go from this, we'll go all the way to A. B bar and C bar. Get it? Now, we notice that the output of each one of these gates, they're all ORed together, right? So let's bring this one in here. Bring this one over here. Bring this one over here. Let's bring them in just a little bit closer, shall we? Let's bring this one in right about here. Now we'll just take an OR gate. We'll bring them right in here. It's a 3-input OR gate, right? You're coming out. Here's Y. Get it? Let's write each of the terms. Why not? So this is over here. This is A bar, B bar, C bar, right? This one here is going to be A bar, B, C, and then this one's going to be A, B bar, C bar, right? So, if you notice, what we just did is we took a truth table, which is right here. Here's your truth table. We then came up with an expression for it, for when Y equals 1. Then based off of this expression, we then came up with a circuit, which is right over here. And then obviously we came up with the answer, which is Y, and Y equals what's up there. Okay? So right there, you have a very good example of SOP. Okay? See you shortly.